Hello, welcome to my channel. We will be doing question number 3 in mechanics. Okay, this is a interesting question, not very challenging. The situation is there's a race going on, and we have two runners. Let me make the current choice. So one is the leader, he is leading, and he is 200 meter away from the end. Okay, he has 200 meter to go. Okay, and its speed is in a race, the leader is 60 meter ahead of the chaser. Okay, we'll talk about chaser with 200 meter to go, and it's running at yeah, his speed is 4 meter per second. The chaser is behind, and he's 60 meter behind this one, the leader, right? Okay, and his speed is 5 meter per second. Okay, this is the scenario, and this is the end of the race. Okay, now find the minimum constant acceleration required by the chaser to catch the lead runner. Okay, first of all, this lead runner is going at 4 meter per second. He has a covered distance of 200 meter. So how much time he will take? He will take 200 divided by 4. So this is 50 seconds, right? So the leader is going to reach at the end point in 50 seconds. Okay, now if he wants to catch him, right, what should be the acceleration? Because if he keep going with the same speed for 5 meter per second and distance is 260, so he will take how much time? 260 divided by 5. So this is going to be 52, 52 seconds, right? So that means if he keep going with the same speed, 5 meter per second, he will never catch up. Okay, the leader will reach over there 2 seconds before him. Okay, so if in order him to catch up, he need to accelerate himself, right? Okay, so now how much should be the acceleration? Okay, remember the equation S equals VIT plus half AT squared, right? You might be using U instead of VI, but mean the same thing, the initial speed. Okay, so we will apply this equation. So the distance he has to cover is 260 meter, right? Because from here 60 meter plus 200, this is the distance he needs to cover. His current speed is 5 meter per second. Time he has is 50 seconds, right? With 50 seconds he has to reach over there because the margin given by the leader. Okay, plus half A we need to find out, and time is again 50 squared. Okay, so in this equation, we will solve it and find the value of A. So you can see it is 260 minus 5 times 50 is 20. 250 equals, uh, here I have 50 squared by 2 and A, right? So I can do this thing 2 times 260 minus 250 over 50 squared. This is going to be A. Okay, so A is equal to, this is 260 minus 250 is 10, 10 times 2 is 20, 20 divided by 50 square is 2500. So 20 over 2500, this gives us 0.008 meters per second squared. Okay, so this was our part 1. Okay, now let's do, so this is A. Now let's do B. Okay, if the lead runner is actually accelerating at a constant rate of 0.05 meter per second, find the minimum constant acceleration required by the chaser. Okay, now the lead runner, his current speed is 4 meter per second, and he's accelerating with this acceleration. So of course, now he will reach here earlier, not in 50 seconds, but a little less than this one, right? Okay, so how much he will take now? Um, okay, so for him, the distance he needs to cover, I will again use the same equation. Okay, so S, the distance he needs to cover is 200 meter. His current speed is 4 meter per second. Time we need to find out plus half, and acceleration he has is 0.05, half a and t squared. Okay, so let's solve this equation and it will give us a value of t. Okay, you can see it is 0.05 divided by 2 is going to be 0.025 t squared and plus 4t and minus 200 equals 0. I'll just multiply the whole equation by 4. No, sorry. I divide it by 0.025, so it becomes a little easier, t squared and plus, this is going to be 160t and minus 8,000. It is not necessary, you can solve it without it as well, but it looks a little nicer. And now if I solve it, it's a quadratic equation, so t is equal to minus b plus minus under the root b squared 160 squared minus 4 times a, which is 1 into c. So this is minus and 8,000 and divided by 2a. So 2 times 1. So this solution gives me two values. One is 40 and one is minus 200. So of course this does not make any sense. So we take 40 seconds. So you see, if he keeps going with the same speed, he will reach at the end in 50 seconds. But if he's accelerating, he will reach there in 40 seconds, right? So now this chaser, he has to accelerate even faster if he want to catch up, right? So now what we will do, we will again apply the same equation that distance he needs to cover is 260. His current speed is 5, but now the time he has is not 15, but it's only 40. And plus half a we need to find out and 40 square. Okay, so again we will simplify this equation. This is going to be 260 minus 200. 5 times 40 is 200, and this is equal to 40 square over 2a. So acceleration is going to be 2 times 260 minus 200 over 40 square. Okay, so this gives us an acceleration of 0.075 meter per second square. Okay, you see, so first, if the leader is not accelerating, then he will reach at 50 seconds. The chaser has 50 seconds to go, so he needs an acceleration of only 0.008. But if the leader is accelerating as well, the time we have is less, not 50, but only 40 seconds. And in 40 seconds, if you want to go, then the chaser has larger acceleration, and that's going to be 0.075. Okay, I hope this is interesting and you enjoyed this question. Thank you very much for watching. See you in the next video. Um, bye bye.